Hi guys, today we are going to take a little bit of different approach to finding the domain of a composite function. Yesterday we did it algebraically, today we're going to do it graphically. So we're going to graph the function g of x, which is x squared minus 4. So we're going to draw an exact picture of this as much as we can. And you guys know what that parabola looks like. So I would have a picture that looks like this. And now I'm going to graph the function, the square root of x plus 3, which shifts us to the left 3, and then up 1 over 1, up 1 over 3, so to here. And I'm going to get a picture that looks like this. The domain of this function is going to be x is an element of the real numbers, okay? And the range of the function is going to be y is greater than or equal to -4. Now, I'm not so much worried about the range of the function as I am the domain of the function. So for this one, the domain of this would be x is greater than or equal to -3, and the range is going to be y is greater than or equal to 0. Okay, so it says shade the y values of the graph where the function is part of the domain of f of x. Because this is asking me, this is going to ask me to find f of g of x. So since this is greater than 3, I'm going to shade my function. Here is, I need greater than -3, so the range would be here, and it would be here. Right, the composite function is defined by f of g of x. So that composite function would take the inner function and put it there. So I would have the square root of x squared minus 4 plus 3. Which would become the square root of x squared minus 1. So that would be the composite function. And then if I want the domain of the composite function, I want to know what x values make our highlighted y values possible. So the domain of this would be -infinity to -1 union 1 to infinity. Again, the range is not that important to me. So when I'm looking here at the range of this problem, I can see it's a square root problem. So the range of the problem is going to be y is greater than or equal to 0. Okay, don't really care about the part B part of that question. So now I want you to think about this. So the way that you do the problem is you find the domain of the outer function, that's the first thing you're going to do. And then you're going to mark the domain on the range of the inner function and then write the domain that is in the highlighted area, that makes the highlighted area. So find the domain of the outer function, mark that domain on the range of the inner function, and then find the domain that makes the highlighted part possible whenever you are writing that equation down. So let's take a look at this. It says we're going to find the composite function f of g of x, and g of x is x cubed minus x cubed plus 1. So I know that function looks like this, and we don't have to be perfect on this, we just need to be close. Right, so there is the g of x function. And then f of x is log base 2 of x. So we know that we have an asymptote here, moves over 1, so that this is what a picture of the log function looks like. Okay, so this is the outer function, this is the inner function, and then the domain of this function is x is greater than 0. Okay, so I'm going to come over to the outer function, and I'm going to take the range of that, which would be here. So there is where the function is greater than 0. So this is going to be open. So the domain of the composite function would be from x is greater than -1, because that's the x that makes this possible. All right, we're going to find g of f of x this time. So f of x is the absolute value of x minus 2. So up 1 over 1, up 1 over 1. So I know I need to be able to figure out what I need with this. So this piece is going to look like that. And then I know this one is going to come here. So that would be what my function looks like. So this is the g of x, this is the f of x function. G of x is negative absolute value of x, 4 minus x plus 2. So I'm going to go over 4, or up 2. And this is going down and backwards. So down 1 over 1, down 1 over 3. So you get a graph that looks like this. And this is g of x. And this domain is x is less than or equal to positive 4. So I'm going to come over to my inner function, 1, 2, 3, 4, and there is where this is equal to 4. So I need this piece of my graph, and I know this can extend out this way. So I need the x's that make that possible, which is going to be 1, 2, 3, 4, 5, 6. So from -6 to +6. So the domain of g of f of x is going to be from -6 to +6. Draw in the y's and put it with my x's. All right, last one. Find the domain and range of the comet. So I'm doing f of g of x. And g of x is going to be over here. And it is x squared. So I have this function. And f of x is 1 over x. So that becomes my inner function, which is all real. This problem would be, so this domain is x cannot equal 1. So when cannot equal 0. So when I come here, this is going to be open. And I would have a picture that would be this. So the domain of the function would be -infinity to -1. To 0, union 0 to infinity, or x can all real, x cannot equal 0. So I know this can be a little bit confusing whenever you're doing this. So what you need to make sure that you're doing is just remembering, find the domain of your outer function, mark it off on the range of your inner function, and then write the domain that makes the highlighted area possible. So I hope you found this helpful. It's a kind of nice, short little lesson today. And then you will have a little worksheet that you're going to have to turn in.